guys, so in this lesson we're going to learn about 11-2, comparing data sets. So we're going to take what we did last class and we're going to compare it to a different set of data sets. Okay, we're going to use the same data that we used last class. We're just going to make it a little different, okay? So coach wants us to compare this year's football season to last year's. We are going to use a dot plot, a histogram, and a box plot to compare the data. So those are all things we learned about last class, or last video. So this is just kind of an extension on it. So, in example 1, we're going to use a dot plot to compare this season's scores to last season's scores. So this is the dot plot that we actually made last video. Okay, we made this in our last video, so if you haven't watched the last video for 11-1, I suggest you watch that. So I didn't change anything. It's the same exact dot plot that we created. I literally copy-pasted. Okay, this is last season. So 2018-2019 season. This is the dot plot for that. And I just want you guys to take a minute to think about it. So in this season, we've got this kind of a cluster in the 30s and 40s, where last season we've got a cluster in the teens and the 20s. Okay. Now look at the maximum. And also look at the min. Okay. So if high score is the most important feature, in which season did Lakewood perform better? So do not look at clusters. Do not look at the fact that this season we scored higher generally than last season. Just look at the highest score. Well, the highest score that we got this season was 49. But the highest score we got last season was 62. So if we're looking at just highest score, last season would be where we performed better. Okay? If we're just basing it off a highest score, last season. Okay? But coach wants more information about the average. So average is just another term for mean. So mean means average. Average means mean. Okay? So he calculates the mean, which is, again, the average, and the mean absolute deviation. I'm not going to get into the definition of that, but it's more about variation. So mean absolute deviation is about variance, how much a variety of scores there are of the two data sets. How can these measures help him make a more informed decision about which season was better? So, okay guys, to calculate mean, you add, so to calculate mean, this is for this season. To calculate mean, all I did was took all the data points and I added them together. I got all these numbers, the 7, 21, 29, 31, 35, 35, 35, 38, 38, 40, 43, 48, and 49. I got all those out of the dot plot. Okay, each dot represents a data value. That's why there's 3 35s and 2 38s. Okay. So all I did to calculate mean was add them all together. Okay, so let's add them all together. And I got 449. Then you are going to take that number and you are going to divide by how many terms there are. Now there are 13 terms because we played 13 games. So we're going to take 4 and divide it by 13 because like I said, we have 13 data values. We played 13 games. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13 games, so we're going to divide by 13. 449 divided by 13 is 34.53. That is how I got that number. So we can do the same for last season. The mean for last season. And all I did was add all the numbers together. Okay? And when I added all the numbers together, okay, I got 298. Excuse me, I actually got 283. I added wrong incorrectly on my calculator. Hey, we all make mistakes, okay? And then again, you are going to take that 283 and divide by 13 because we have 13 value points. We played 13 games. So, all right, so when you divide it by 13, I got 21.77. That's how I got that, okay? So those are our means. On average, this season, we scored higher. We scored a 34.53. Last season, okay, our average score, our mean score was 21.77. So we scored about 22 points on average every game. So, okay, guys. MAD, you need to know how to use it and how to interpret the data, but it's not essential that you know how to calculate MAD or mean absolute deviation. So, to calculate the mean absolute deviation, you take each value and you subtract the average, the mean, okay? So if you see here, I literally subtracted the same exact number every single time. I subtracted the mean. Okay, these bars right here, so these bars, okay, those two bars, these two bars right here, okay, that you see on the ends, that means absolute value, and it's always positive. It does not matter, okay? 7 subtract out 34.53 actually gives you negative 27.53. Because it's absolute value, it's always positive. Always, 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 always positive. Okay? So every single one of these has a bar. Okay, they've got two bars on the side. You see, okay? Then we add, okay, all the things we get from subtracting, okay, we add them all together. Now I multiplied by 3 here because this appears 3 times in the data. Okay, 47 came 3 different times. So, I put the 3 there. Same with 3.47. That happened twice. That's why I multiplied by 2. So you add them all together, okay? And then you get 100.25. Then again, we divide by 13 because we have 13 data points. When I divided by 13, I got 7.71. Okay, so I did the same exact process. I did it again, but for last season, and got 7.62. So, okay, in conclusion, okay, this season had a higher mean, or had a greater mean, at 34.53, I believe, yep. .53. Okay, but last season has has less variance. Okay, so less variance, it's less variety. Okay, it's not as spread out. Okay, because the MAD, or mean absolute deviation, is 7.61 compared to this season's 7.71. Okay, so last season has less variance, but this season our mean was greater. Okay? Perfect, guys. So it's something to really look at, okay? According to the mean, this season was better. But according to the mean, the MAD, okay, last season was better. So it really depends on what your conclusions can change based off of what data you're actually looking at, okay? So, and what you want, okay? Do you want more variety? Is it okay that there's a widespread? Or would it be better to not have widespread? So, for this instance, I think last season, or this season, was better. Right? There was more deviation, there was more variance, but our scores were generally higher. We had a higher mean. Okay? Alright, guys. Let's keep going. So in example 2, Coach wants us to analyze the distribution of the data sets. Coach claims this season had more consistent scores. Is his claim correct? Alright, guys. So, this is a box plot. We've looked at this before. I made a, I kind of made my own version. This time I actually found a graphic for it. But this was the same data that we've been using for this season. Okay, our minimum is 7. Okay, min is here. Max is over here. This is our median. First Q, or first quartile, and third quartile, third Q, alright? Okay. Now, to get the IQR, okay, and IQR stands for interquartile range. So interquartile range is found by taking, so you find this by taking the difference of the third quartile, and first quartile. Okay, so we took 41.5, which is our third quartile, and subtracted out 30, our first quartile, and that's how I got the 11.5. Okay, this box here in blue, that's like 50% of our data. 50% of our data is in that box. Okay, so there is 11.5 difference in our box. Okay, so that's our range. So let's also look at last season's data. So last season, okay, our minimum was 10. Our max was 62. Okay, the median is at 20. First quartile is at 13.5. And third quartile is at 23.5.